Let's see how this plays out in problem 18 on the first page of your notes shell. All right. So, is there a picture that might help on this problem? Yeah.
Like if you draw a line and you label it as X, and you draw another line and you label it as 3X.
Well, drawing a line to represent the pipe is good. What I'm going to do is, instead of drawing two separate lines, I'm going to draw the one line here and draw our cut, our place where we cut the pipe, here and here. Now, calling these X and 3X is a good idea, ultimately, but we've got to define what X is first. Okay, but it's not a bad start here. What else do we know about this length of pipe here?
We know it equals 20.
We know its total length is 20. So we know this total length is 20 feet. Let me just check and make sure that our online viewers can see up that high. Oh, no, they can't. Now you can. So, we know the total length of this pipe is 20 feet. We know that this piece, the longer piece, is 3 times the length of the shorter piece. But let's go ahead a little bit before we start labeling that, because you've labeled it right again. Or your idea to label it is right. And let's go with a let statement. Because what I want to get you into the idea of is saying that throwing X's around, whether it be in a picture or in an equation, makes no sense unless you know what the heck X stands for. So what is X going to stand for? Now, what a lot of people want to do, I start with a statement with let X equals. A lot of people want to fill in the blank with 5, 15, 27, a number. That's what you want, but that's not what we're doing. That's not what the let statement is about. The let statement is about defining what the heck X is going to represent in this problem. And what physical quantity is X going to represent in this problem? But are they both? Okay, so you say the length of each piece. Problem is, this piece is longer than this piece. So are they both X?
One of them's going to be more X.
One of them's going to be, one of them's going to be bigger.
Right.
So which piece do you want to call X?
The small one.
Okay, so let X equal the length of the smaller piece. Notice I said length of the smaller piece. I didn't just put smaller piece because I might have been referring to its length. I might be referring to its weight. I might be referring to how old it is. X refers to the length of the smaller piece. Okay, what else then do we know? If we know X is the length of the smaller piece, we know the longer piece has got to be
3 times bigger.
Yeah. So the length of the longer piece is 3x, 3 times x. Now, I understand if you think that this is a lot of work to go through for something Chad was able to answer in 2 seconds. Oh, it's 5 and 15. But realize again, it's easy to get confused on these. You know you've done them in the past. And it's easy to get off the track on them. And you need to be able to justify what you're doing. And so that's why this step of modeling makes sense. Notice also what we've done is the temptation for Zena was to say, Well, the pieces are what we don't know, so let x equal the pieces. Okay? And actually, it's really the length of the smaller piece and the length of the larger piece. Now, I've screwed up here. I forgot to do something. What did I mention? Look at your list. What did I forget to do? I have to say what we're thinking of finding. So, now we are trying to find something. So this is really what should have been written first. We're trying to find something. Find what? The lengths of the pieces. But that's probably not the best way to phrase what it is we're trying to find. Because we want to name each thing we're trying to find. So, what I will suggest in a find statement, a good find statement, will be that you list the things you're trying to find. That way, your x is going to be one of these things. And chances are the other is going to be something like 5 minus x, 2 times x, whatever. But if you have them listed as each separate thing, so each thing, each quantity you're asked to find, should have a name in this find statement. And then we give it a nickname in terms of variable names. Let x equal the length of the smaller piece, 3x equal the length of the longer piece. Now, by the way, is a good chance to label, as Lacey suggested, the diagram with x and 3x now that we've decided what x and 3x represent. So now, we get to the point where we want an equation. We want an equation here. Well, what equation is suggested by that picture? Yeah.
20 divided by 4x.
We could go simpler than division. Even though we are cutting it up into that many pieces, we could go simpler than division.
3x plus x equals 20.
Yeah, there's this length plus this length is 20. The long length plus the short length is 20. And now we've got something that we did that's like the test questions. 3x plus x is 4x. We want x by itself, so we divide by 4. Have to divide the other side of the equal sign by 4. We've got x equals 5. So that's solving the equation and setting up the equation. Now we have to state the conclusion. The shorter piece is 5 feet long, and the long piece is 15 feet long. Let's see if it checks. First of all, it matches Chad's original answer. Second of all, do these things add up to 20 feet? Yes, they do. Is the shorter piece or 1/3 of the length of the longer piece? The long piece 3 times the length of the shorter piece? Yes, it is. It checks.